Sorry, here we go. Um, number 16. You should never, look, will you please look over here? You should never have the center line as a solid line if it's not at the axis. I'm having people that would do something like the center line. What was the center line? 1? They call this a solid line, and that's, you don't do that. The solid is for the curve and the axis, period, not for the center line. If the center line's not the x-axis, then it should be dotted. Are your important points then 105, 375, 645, 915, and 1135? Okay. 17. The original problem, I don't know if that's the original problem, but hopefully at some point you made was secant squared the original in top, or was it something else? Yeah. Okay, so hopefully you change the denominator to inverse tangent, or not inverse tangent, tangent, and then maybe did some sine cosine action to get cosecant squared is the best way to go. Yes. Okay. For 18, I hope you got a common denominator. When you get a common denominator, this is what it should look like: sine squared plus cosine squared of the numerator, which is then 1, and 1 over sine is cosecant. The 19, you should have done a negative angle of cosine being the same as negative cosine being the same as cosine of a positive angle. Sine is the opposite. Cotangent is the opposite. She's doing
Is that 3 changes in 1?
It sure is. I didn't do this. That's a lot.
So are we not allowed to do that?
You are not allowed to do that.
So I'm not doing it like that.
Okay.
I'm just being very angry to do work.
It should be one substitution per step is the way I've taught you. But eventually you get a lot of sines dropping out and cosine over cosine, which is 1. 20, I hope you took the log of both sides base 10 and eventually have something like 1.436. 21, log base 3 of both sides, and x equals 1. Very good. 22, law of cosines is c equals 5.386. 23, the order they did stuff was angle B first, 52.617. Then you could do law of sines or cosines, but angle C is 44.049 degrees, and angle A is 83.325. Yes?
For number 20,
Yes.
that wasn't a plus sign, a plus log, or it was times, so why did it turn to plus here?
Yeah, good question. So, I'm so glad you asked, because this is one of the hardest types of log problems, is when it's not just a term and a term. Thank you. I didn't even see that. So the original problem is this: 10 to the 3 times 2 equals 5. 2x minus 1 times 10. Okay, so wouldn't you agree that to get rid of log base or exponential base 10, you want to log, yeah? Okay, this is the idea that I want to emphasize, is that when you log, it cannot be log here, log here, log here. You cannot do that. Instead, it must be log a whole side at a time. Now the left side is super, it's 3x minus 2, but the right side is not, okay, now I give each of those a log. That's a no. Instead, the log of two things multiplied, if you want to break that up so you can do each one separately, the log rule is that that's the log of a plus the log. And so that's what's going on, is that when you take the log of the left side, the whole left side, it actually turns out to be a sum. Thank you for asking. I didn't even see that. Okay? That is a rough one, so be careful when you have a problem. 23, I think we said 24 is 2i negative root 3 minus I, and I think that says positive root 3 minus I. All right. 25, the positive root 3 minus I. Yeah. You have one that's two negatives and one that's positive negative. 25 is, how do you know if it opens side to side or up and down?
The bigger one.
If X is first, then it opens sideways. If it's Y is first, it opens up and down. Part of the things we're going to talk about this week are why is the homework not paying off on the test? Because constantly I'm saying, yeah, I get that, but on the test, you don't get that. I mean, the tests were disaster. So we need to do a little better job of being honest with ourselves. Yeah, I didn't get that, or I had to look it up in my notes, and I can't do it by myself. Whatever is the disconnect between our homework and our test, we've got to figure it out, because we need to do better. At any rate, by the time the test rolls around, there should be no graphed it up and down when it should have been decided. That mistake should have been made and hammered out long before the test. And you need to, if you have to look at your notes, then it needs to be for the first few days and not after that. If you're using your notes as a crutch, it needs to stop. So if when you put it in standard form, it's x squared minus y squared, then it should open this way. If it's y squared minus x squared, then it should open that way. It has nothing to do with how big the numbers are. It's which one's positive. Okay? The foci, did you see the foci are at 5, 0 and negative 5, 0? Okay. And the asymptote equations are plus or minus 4/3 x. Oh, did I not do the bottom? Was there more? No. Okay. There is 26, 1r cubed plus 3r squared s plus 3r s squared plus s cubed. You guys did well on those on the test. That's good. Number 27, I don't remember what the question was, but 6.681% caused you to say yes?
It was like what she ate in the top 10.
Okay, gotcha. All right. So hopefully that makes sense. 25, you have two ellipses, and you're shading the overlap. It looks like this is also a bit of a mixed bag. On this guy, what's the length of the minor axis? Okay, so minor axis, does that kind of indicate big or little? Little. Okay, so would you agree that we're looking this way? Now the question is, do I say 2 or 4? 2. It's the whole thing, the whole axis, and it's 4. Okay? So that didn't go well on the test. 29, your perpendicular line is y equals x. That's nice. The intersection point is 2, 2. That's pretty nice. And the distance then is 2, 2. And 30, are these are not replaced, right? Does this match what you have? Okay. And then 30 is 24/5. All right. Is there more? Are there more? Is this what you have? Okay. So you should have a horizontal asymptote at y equals 0. Is it y equals 0 or x equals 0? Y equals 0, and the points should be 0, -3, and -1, -1. You know exponential graphs because exponential graphs have a blank asymptote.
This way.
Horizontal asymptote. You know log graphs because logs have a vertical asymptote. That also is not great on the test, matching or which of these is a log graph. A lot of people miss that one too. This homework is, did I double up any points? That distance from a point to a line was 2, so probably 22 points total.
Oh, we're not.
No,
That's-
3 points that question.
Oh, I'm sorry. Oh, there's more? Let's go with, let's go with 1, it's old. Okay. The area inside that figure is 300 square feet. The picture here, because inverse cosine is first and second quadrant, you should have been drawing a negative in the second quadrant, and cosecant then is the reciprocal of sine. So 5/13 D is, hopefully you graph this. So this is right 4 down 3. So this yields a triangle like that, okay? You should not just be doing inverse tangent of this or inverse tangent of that, because it's more complicated than that. You don't know what quadrants it's in until you draw it. So you should be drawing it. If you don't draw it, it's probably not gonna be right in most cases, all right? So hopefully you drew the picture, you found the angle by inverse tangent, subtracted from 360, and then you use Pythagorean theorem for the hypotenuse. F, there are two asymptotes. What are the two asymptotes? Y equals 0 and x equal 3. Is that all? Okay, Philip, how many missed and put that at the top. And I will turn up the old notes. Yes, sir.
For D, if we didn't draw it, should we mark it wrong?
No. All right, here we go.
I didn't bring my binder today.
I think so. We'll see. I'm a terrible judge, apparently. So here we go. Arithmetic sequences and when you read sequence, think pattern. Okay. Thank you. Now there are lots of types of patterns. There's geometric and arithmetic and Fibonacci and come on now. So this is just one type of sequence. It's the most logical, I think. All right. So it goes like this. A sequence is any kind of list that typically follows a pattern in math. It's not a random list. It follows some kind of pattern that's predictable. Now I know that we're used to reading that word arithmetic, but in this case it's pronounced arithmetic. Arithmetic sequences. Arithmetic sequences, their examples are like these: 7, 10, 13, 16, 19. Could you give me the next number? 22. Okay, it's a pretty logical pattern where you're just doing what each time? Adding 3. Now, this can, I know it sounds like on that level it's super duper easy, and it's true, on that level it is easy. But if you want to find the 700th term, well then you have to be a little more thoughtful. And if instead of I giving you the first term and the second term, I gave you the 10th term and the 40th term, well, things get a little more complicated, okay? So let's build up to those ugly cases and look at the big idea of the day. So in this guy, this is, I'm going to call this, rather than 1, I'm going to call this A1. A really represents a term in the sequence. A is a term in the sequence. For this first one, A1, or the first term, is 7. A2, or the second term, is 10, and it came from taking 7 plus 3. A3, or the third term, came from taking 7 and adding 3 twice. Adding 3 and adding 3 again. A4 came from adding 3 how many times? 3 times. How come it's the fourth term, but I'm only adding 3 times? Well, how many times did you add 3 for the first term? None. Okay, you didn't add any 3's to get the first term. So it's always 1 less. The second term is adding 3 once. The third term is adding 3 twice. The fourth term is adding 3 times. The fifth term is adding 3 4 times. So couldn't we say that the fifth term is like starting with 7 and adding 3 4 times? Couldn't we write it something like that? Yeah? 7 plus 3 4 times? And isn't A3 like 7 plus 3 3 times? And A3 is like 7 plus 3 twice. And A2 is like 7 plus 3 once. And A1 is like 7, not adding 3 at all. You with me? So what would you say the nth term is? Give me a formula. Each time, what'd you do? 7 plus 3. How many times? N minus 1 times. Again, it's 1 less because we don't add to get the first term. It's always 1 less than the term number. So I could get any term by just saying, I'll start at 7 and add 3 1 less time. So the 50th term would be 7 plus 3, 49 times. And the 100th term would be 7 plus 3, 99 times, and so on. Easy to find any term down the line. You with me? Okay, look at the second sequence. Subtracting 4. It's subtracting 4 each time. So the first term is 7. The second term is starting with 7 and subtracting 4 once. The third term is subtracting 4 twice. The fourth term is subtracting 4 thrice. And the fifth term is subtracting 4 times, yeah? What about the nth term here? The nth term is starting at 7 and subtracting 4 or adding -4 how many times? N term is subtracting 4 n minus 1 times. You see where I'm coming? Generally speaking then, in an arithmetic sequence, you always look at any number term or the nth term in the list can be found by taking A1, which obviously represents the first term, and adding D, which is what you increase by, or the common difference it's called. That's why they call it D, for a common difference between the two. And N is the number of the term. Now, if you were to, maybe off to the left in the left margin, if I were to graph this first list, the first term is 7, yeah? The second term is 10. We went up 3. The third term is 13. We went up 3. The fourth term is 16. We went up 3. What kind of pattern is it? Yeah, arithmetic is linear. Linear. In fact, this might look familiar-ish. If you do point slope form and move over y1, then you get pretty much the arithmetic sequence point. Arithmetic is just a line starting from some starting point and going up and over. So this common difference is like the slope. It's the rate at which you're changing each time. You following me? Okay. Okay. Now let's look at a few problems here, and we'll use the formula as a guide. But I'm not a slave to the formula. I'd rather you just think a little bit and use the formula and thinking together, not just I've got to use the formula. I've got to plug into the formula. I'm never going to think. Okay, just little bit. All right, that's all I'm asking. Write the first four terms in the arithmetic sequence whose first term is negative 14 and whose common difference is 10. Well, it's really easy to write the first term. All you need is vision and the ability to read. And it's negative 14, yeah?
Yeah.
All right, now the other terms are not hard either. The common difference is 10. It's positive, so we add 10. So the next is negative 4. Add 10. Then add 10 again. 6. Negative 4 plus 10 is 6. And add 10 again. 16. Now, to me, it would be absolute foolishness to break out the formula and use it every time. That's really overthinking. Wouldn't you agree? That's easy. Okay. Now, find the 25th term of an arithmetic sequence whose first term is 12 and the common difference is negative 6. Now this, I definitely don't want to list terms. I don't want to start at 12 and add negative 6 and add, to get to the 20th. That's a waste of my time. So now I'm going to use the pattern. The 25th term can be found by starting somewhere. Where do I start? Okay, let's use the formula. A1 and common difference, n minus 1 times. So A1 is 12. What are you adding each time? Negative 6. And how many times will you add it to get to the 25th term? 24 times. Yeah? The more you write a formula, the quicker it gets in your brain. So write the formula, then plug in. Negative 6 24 times will be a total difference of negative 144, I believe. So if you take 12 and subtract away 6 24 times, you end at negative 132. Do you agree? Something a little more response. You're just waiting for me to go. Do you follow me there?
Yeah.
Okay. Does that make sense that we are so much lower than where we started? Why? Because we subtracted 6 every time. We're going to get smaller. I mean, aren't we going to get smaller pretty quick and start heading into negative territory? So yeah, that makes sense. We'd end in a negative territory. Yeah? Okay. Find the 3 arithmetic means in between 2 and negative 4. Now, arithmetic means are missing numbers, as it says, missing numbers between 2 terms that are known, right? So when I say find the 3 arithmetic means in between 2 and negative 4, then it's really like they're giving you A1 and A5. You see we have A2, A3, and A4 missing, so we have A1 and A5. You follow? All right. Now, let's look at this in terms of finding the common difference. Let's think of this in a slopey kind of way. What's the total change from one to the other? Like slope, its total change is negative 6 because we went down 6, yeah? That's the total change. I'm going to say that's the change in the terms. And I'm going to divide that by how many terms we took differences between. How many total differences did we do going from 1 to 5? How many jumps did we do? 1, 2, 3, 4. There are 4 jumps from A1 to A5. Or if you like, 5 minus 1. Now you can, actually I'm going to write this. I just said it was like slope, but then my work was a total slot fest. Okay? So I just took the difference in the terms. The total decrease was, it went down 6 altogether, divided by the term numbers, 5 minus 1. So it seems like it's going down 1.5 each time. Write that in your notes. This is the change in the terms divided by the change in the term numbers for how many jumps. To get from 1 to 5, you make 4 jumps. You follow me? Each jump then is negative 3/2 or negative 1.5. Now, based on that, if I start at 2 and go down 1.5, where does that put me? 0.5 or 1/2. Then I'm going to be at 1/2 and go down 1.5. Where does that put me? 1/2 minus 3/2. 1/2 minus 3/2. -1. -1 or -2/2 minus 3/2. -5/2. And let's just check. -5/2 minus 3/2 more. Puts me at -8/2. And that is -4. Okay? You with me?
Yes.
All right. Lots of different types of problems. You'll get a mixture, and if you understand the big idea, you just have to be careful. Right? The first 5 terms of a sequence where they give me the 17th term is -40, and the 28th term is -73. Phew, that's a mess. All right, let's start by finding the common difference based on what's given. Now, I just said the difference is like the slope. And that's the change in the terms, the total change that happened over the change in the term numbers. In plain old English, I want to figure out what each jump is. You down? In going from -40 to -73, change in the terms was that it went down how much total? 33. It went down 33. And going from -40 to -73, it went down 33. With me? That was over how many jumps altogether? Over 11 jumps. It decreased 33 in 11 jumps, so each jump or each difference must be -3. I'm not, don't be a second to the formula. Just think of how is it changing. It changed a total of 33 in 11 jumps, so each jump is 3. You cool? Okay, now I will use the formula here. The formula for any term is the first term plus oh so many common differences. Let's focus on the 17th term. Use the 17th term. Now, the 17th term was -40. And it must have come about from starting at some first term that I don't know and doing what? Going down 3 and how many times? Now there's 2 ways to figure out what goes here. One is just to say, what is n in this case? N is 17, yeah? But we want to talk about the 17th term. So one way to know what to put here is to just say, I know that when I'm talking the 17th term, n is 17. Okay? Another way is to do this more in a common sensey way. I know that I would get to the 17th term by starting at a first term and adding -3 16 times. You cool? So how do I figure out what the first term must have been? Well, I got to -40 by adding or subtracting 3 16 times, so I must have started at 8. I got to -40 by subtracting 3 16 times. I must have started at 8 to begin with. Now we're getting somewhere. The question was find the first 5 terms in the sequence. What have I found? First term is 8. How do I get the next term now? Add -3. So what was the second term? 5. And the next? 2. And the next? And the next? Okay. Would those eventually get to -40 later on, and then -73 even later than that? Okay. That one was a little harder. We had to do quite a bit of work there. All right. Find the 8th term in an arithmetic sequence whose first term is -1 and whose 5th term is 1. So I want the 8th term, yeah? And I know the first term is -1. but I don't know second, third, fourth. I don't know anything till much later at the fifth term. You follow? So, again, find the common difference. How it jumps. Once you have the common difference and the starting point, you can do anything you want. So how do I find that common difference? It's like the slope. It's change in the terms over change in number of terms. How much did the terms change in going from -1 to 1? 2. They went up by 2. How many jumps did it take in going from A1 to A5? The change in terms was 4. So it seems like each jump is 1/2. Let's verify that works just by filling in the dots. If I start at -1 and add 1/2, then what's A2? A3? A4? And it checks that A5 then is 1. Now we could find A8 by using the formula, but we could just as easily find it by continuing on the pattern. What's A6? 1.5. What's A7? 2. And what's 8? 5/2 or 2.5. Okay? Okay. Find the 10th term of every arithmetic sequence whose first term is 3x plus 2y and whose sixth term is 8x plus 12y. Now this is where things get a little funky. Okay? We want the 10th term. And what were we doing each time? The very first thing we need to find is the D, common difference. Find the common difference first.
Can you do X and Y separately?
So that's a good question. Let's see. I suppose you could. Let's not, shall we? Change in the terms. Change in the terms means take the difference between the terms. So do I start with 3x plus 2y or 8x plus 12y? 8x plus 12y, take away the first term, which was 3x plus 2y. How much did the x change by? 5 x's. And how much did the y's change by? 10 altogether, yeah? Now divide that by how many terms? We went from the first term to the sixth term, so the change in term numbers is 5. 6 minus 1, or 5. So each jump then, D represents each jump. How much does x jump by each time? 1 single x, and the y's jump by 2 y's. Okay. So, to find the 10th term now, because we went 12y down to 2y, so we must be subtracting y's over and over again, yeah?
We went up because A6 was the first term. The sixth term was 12.
Oh, good question. I have no idea. You're right, sorry. They were going up by 2y's each time, sorry. On the 10th term, I could either start at the sixth term and build up, or I could use the formula. What do you want to do? Tell me, what do you know about the 10th term? It's not 10 away from anything. It's 9 away from the first term, yeah? You could say that A10 is 9 differences away from the first term. How far is it away from the sixth term, if you want? Yeah, so it's like the 10th term is like the sixth term plus not 5. How many terms is it away from the 10th term? How far is it from 6 to 10? 4. Okay, 4 differences, all right. 4 differences. Either way, students should typically like to just use the original formula. What's the first term? 3x plus 2y. It's given. It says the first term is 3x plus 2y. Okay? What is a common difference, then I'm gonna add 9. How much does it go up by each time? X plus 2y. Alright, so when I do this and find the 10th term, as far as the x's go, they started at 3x. It goes up by an x 9 times. Where does that put me? 12x. Okay? The y's started at 2y and went up 2y 9 times. So altogether it went up 18 y's from 2y. That puts me at 20y. All right. Now then, I really feel like you need to practice this, but I guess we'll do the ones off the homework. So, there goes somewhere homework. The new ones, I will look up and have you. Okay. Let's start with set 86 numbers. 6. So 7. First 5 terms of an arithmetic sequence whose first term is negative 10, common difference is 6. Right, the first 5 terms of an arithmetic sequence whose first term is negative 10 and common difference is 6. This is the very easiest kind. If you can't do this, you really need to come in tomorrow because it doesn't get any easier than this. Okay, so what's the first term?
Negative 10.
Negative 10. What's the second term?
Negative 4.
Third term?
2.
Fourth?
8.
Fifth?
14.
Okay, there you go. 8, find the 30th term. So 830. If the first term is, I lost my place, 5, and the common difference is negative 4. Ready? Okay, what'd you get for an answer? 10 what? Negative 10 something? Starts at 5 and adds negative 4 how many times? 29 times. To get to the 30th term, you add negative 4 29 times. That's negative 108. Nope. Negative 116 plus 5, and that is negative 111. Is that what you said? Okay. Number 9. Insert 3 arithmetic means between 3 and negative 13. So I'm curious, are you hopefully finding the common difference? What's the common difference? Negative 4. It goes down 16 in 4 jumps. So each jump is negative 4. Yeah?
Yes.
Okay, so if you start at 3 and go down 4, where does that put you? And then go down 4 from that. And then go down from 4 from that. And then check with the last. Does that check it ending at negative 13? Yes. Yes. 5.
Oh, I can't. The difference is it? 3 minus 1.
3 minus 1. Why 3 minus? Yeah, but in terms of what you're given, you have A1 and A5. So there's 4 jumps altogether. Total difference is negative 16 in 4 steps. So each step is negative 4. Okay. 10, write the first 5 terms. If the 10th term is negative 30 and the 20th term is 40, find the first 5 terms. Again, focus on finding what one common difference is. What do I do?
Like, I think it was 70 over 10. I think it after that.
Okay, so the difference is it went, did it go down 70 or up 70 in 10 jumps? It went up 70 in 10 jumps, so each jump is 7, yeah? Okay, so there are a couple ways to go. You could do this in a very formulaic way, where you could say 10 is the first plus d times n minus 1. Now, I will teach it that way, but that is definitely not how I think. It was way too much work. I can do this almost mentally. If you instead you think of it this way. Here's the 10th term, yeah? It's 30, negative 30. Each time I add 7, right? If I go this way, I add 7. So this way would be negative 23. We? But I don't want to go to the 11th term and the 12th term. I want to go that way. So if going this way I add 7, then going backwards I must subtract 7. What was the 9th term? Hello? Negative 37. What's the 8th term? Maybe this isn't going so well. 44. Maybe we should find the first term. Would it be better to find the first term for you? I tend to think of things really wacky, and I don't want to confuse you, but how I think, all right? So let's do the formula way. Maybe students will do that. Okay, do you agree that the 10th term I can be found by the formula, okay? All right. Now, I know the 10th term is negative 30. I want to find the first term, so I'm going to call that A1, yeah? The common difference each time is 7, and the 10th term would be after 9 jumps. Do you agree? Okay, so I could think of the first term as the 10th term take away 9 jumps of 63. Again, I started doing my goofy way instead of just sticking with what will make sense to you. So negative 30 is A1 plus 63, right? I must have got the 10th term by starting on the first term and adding 63. Well, that means the first term would have to be negative 30, take away those 63 jumps. So the first term must have been negative 93. You down? Now that we know the first term is negative 93, we can just add 7 to get all the other terms. What's the next term? Add 7. 86. Add 7. Negative 79. Add 7. Negative 72. Add 7. Okay. How got 11. 11 is that wacky kind. Find the eighth term. If the first term is 2x plus 3y, and the sixth term is 7x plus 8y. Let's find the common difference, shall we? So, what's the total change in the x's? 7x minus 2x or 5x's. What's the total change in the y's? 5y's. In how many jumps total was that? How long did it take to go from A1 to A6? How many jumps? 5 jumps. So what's each jump? Each time it seems like you're adding an x and a y. So should we go all the way back to the first term, or should we just build up the sixth term? Which one's closer to the eighth term? 6, okay? So here's where the x's were in the sixth term. Yes? This is how many jumps or difference in terms number from term 1 to term 6. So it's the difference in the end. Okay? So 8x's are at the eighth term. I left off at 7x's. How many x's am I going to add to get to the eighth term? 1 each time, yeah? So how many x's will I end with? 9 x's, okay. The y's, how many y's did I have at the sixth term? 8. And how many y's am I going to add? 2 more y's to get from the sixth to the eighth, and so I'll end at 10. Right? Like pictures of lines?
Yeah.
How does that help you on the one we just did? Hard to graph that.
Like, no, like, I just like this. I just like, because I like the hop.
Sure. Yes. Hops are good. Okay, have a good day. Hops. Maybe I should teach you with hops. It'll be on my website today. Okay. Have a good day. Thank you.
Thank you.
Thanks.